Okay, so today we need to explain is a glow of the bacteria at the different condition. Okay, about the cleaners. Okay, that means the experiment they got call you to put the finger. After that, the finger is after wash with the normal water. Another one with the soap. After that, you're going to see what's the difference for the growth of the bacteria. Okay, now we go through the step by step first. Okay, you need to remember the format. Because this one is one of the compulsory of the question. There's an experiment question type. Okay, let's see here. Now you need to compare the growth of the bacteria on the sterile nutrient. Okay, we put the sterile nutrient. That means the bacteria still got nutrient. That means they can get it. Okay, after that, the nutrient agar, that has been sprayed with the unwashed finger. So this thing you can do, but you cannot see because normally we're using the microscope to see it. So they're using first situation, they're using unwashed finger. Okay, number two, the finger will wash with the normal water only. Okay, number three, they're using the soap and also the water. Okay, so now we're going to see after aim, sure is your, what is that? Problem statement. They're going to tell you the problem statement. So what you need to do. Okay, how does the cleanliness level of the finger restrict the surface of the sterile nutrient agar affected the rate of the bacterial growth? So I highlight already. What is the important point from this one problem statement? They ask about the surface of the sterile nutrient. Then another one is the rate of the bacterial growth. So that means the sterile nutrient later you see the surface. That one is represent the growth of the bacteria. Okay, so if you find it the sterile nutrient above there got so many things. By using the microscope, you're going to see got so many bacteria. That means the rate of the bacteria they grow is very fast. Okay, so from here we need to find out how about the cleanness level. So the cleanness level you control lah. So from here we can mark it. Okay, the cleanliness level sure is a manipulate variable. Okay, later the rate of the bacterial growth sure is a responding variable. Okay, what should be constant? Constant, you can say the nutrient. You give the nutrient. Okay, another one, you also can say the situation, there's a surrounding temperature. You make it become constant. Or you say the surrounding, we give the water. Okay, water also is a constant. So we go through the following. Okay, after the aim, after the problem statement, then we go to the hypothesis. Okay, the hypothesis. So this one hypothesis just like the earlier conclusion. That means I'm not yet to do the experiment, but I assume this one should be the result lah. So when the cleanness level of the finger restrict to the surface of the sterile nutrient agar increases. So that means the cleanness become increases. That means the bacteria grow on the surface of the sterile nutrient agar will be decreases. So that means when you make it become more clean, the surface of the nutrient become clean. So that means the bacteria they cannot grow faster at day. But you said empty is nothing lah. They sure got a little bit bacteria because we got oxygen. Okay, so from here they say the bacteria grow on the surface just decreases. Okay, this one is earlier conclusion what we make. Okay, now we go through to the variable. Okay, variable we need to control. Okay, manipulate variable is the cleanness of the finger. Okay, because just now we say the cleanness level, is it? You can say the cleanness level also can. You can just say the cleanness of the finger when you straight to the sterile nutrient agar. Okay, responding sure is the growth of the bacteria. So from here we call it there's a number of the bacterial colonies on the sterile nutrient agar. You can straightforward just copy from the question, number of the bacterial group. Okay, so the constant variable. Okay, this is a constant variable. The surrounding temperature. So they make sure the surrounding temperature should be constant. If you put the surrounding temperature is a different, that means the growth of the bacteria also be changes. Because later we need to learn about a factor. What's the factor will affected the growth of the bacteria? Okay, so until variable, understand? Okay, anybody can answer me, you understand until the hypothesis and also variable?
contain.
Okay, okay, then we continue to the next. Okay, material. What we need to use, we're using the sterile nutrient. Okay, cellophane, tape, and also the marker pen. Marker pen, you want to mark it. Okay, how many colonies? Okay, the next one is apparatus. Okay, the apparatus, they prepare for the 4 sterile pantry dishes with label. Okay, with the lid and also label A, B, C, and also D. After that, the sterile measuring the cylinder. There's a 10 cm cube. So later they want to put in. Okay, now we're going to see the procedure. Okay, first one they prepare 4 pantry dishes. Okay, after that, inside they got 10 cm cube of the sterile nutrient agar. So that means everyone, they get the same nutrient agar. Okay, then we continue to the second. Okay, now they carry out the following step. First one, they strip the entire surface of the nutrient agar in the pantry dishes with the unwashed finger. So the first one, okay, you put your finger, never wash one, you just touching the whole agar. Okay, second part, you take the pantry, another set. Okay, first one is A, another one you go to wash your hand already with the normal water. Then you just repeat. Okay, after that, you label this one is a pantry dishes for the second one. That's a B. Okay, number 3, you wash your hand with the soap and also the water. Make it become clean. Then you repeat again the step. Now you label this one as a pantry C. Okay, and the last one, the sterile nutrient agar in the pantry D, do nothing to do. Don't do anything. Okay, so after that, we need to cover. Cover the pantry dishes A, B, C, D, and also seal the lid with the cellophane tape. Invert every pantry dish. Okay, anybody can tell me why we need to seal, why we need to close the lid by using the lid to close it lah. Why cannot open? Okay, anybody can answer? Because of the
Bacteria from the surrounding will.
Yeah, because you want to test, is it the cleaners, is it? If I say I open all, that means you cannot compare already lor. All the bacteria also can go in one. Okay, so that means we need to close it. Okay, we need to make it one of the D set. D set is never, don't have anything, your finger never touch one. That one is a control set, so that's why we need to close it. Okay, then we need to see the finger, different part you're going to touch, what's the result. I don't want the surrounding to disturb, so that's why I need to seal. Okay, another one, why need to invert it? Want to invert, okay, every pantry dish. Number 3 procedure, then we continue to the number 4. Okay, this one is the invert lah, terbalik already. Okay, then using the cellophane tape, I'm going to seal. Okay, keep in the inverted pantry dishes A, B, C, D at the room temperature for 3 days in the dark cupboard. Okay, why keep in the dark cupboard? Okay, Kylie, answer me. Bacteria grow better in a place without the light. Yes. Okay, if you put inside under the sunshine, that means you have nothing to see already. Okay, you want the bacteria to come out, grow faster and grow more, then you must keep, all must be standardized, keep in the same dark cupboard. Okay, because they can grow better later. Okay, now number 5, after 3 days, you take out the pantry dishes A, B, C, D from the cupboard. Okay, now you need to observe the number of the bacteria colonies in the every pantry dish. Record your observation in a table. State in the table whether there are no colonies, a few colonies, and or many colonies. We no need to say how many lah. You cannot count so many there, is it? So from here we just say a few, or you say less, or you say no, or you say many of the colonies of the bacteria. Okay, so from here we see the example. Okay, this is a material we need to do. Okay, the water. Okay, you buy the agar. Then after that you're using your water wrap. Okay, then you've got the dishes lah. Okay, after that, from here, okay, we see the first step. Okay, this one not using your finger. This one is a normal. Agar is one of the nutrients, so that's why they're using the agar. Okay, first one, they're using 10 grams of the agar into the 330 milliliter of the water they pour inside. Okay, after that, they go to stir. Okay, stir the solution until they become complete even dissolve inside the water. Okay, so you can see the liquid become like this. Okay, number 3. Okay, they go to make it become solid because this one is a liquid, is it? I want to make the agar become solid. So they put the solution into the microwave. Okay, then put inside the microwave around the 4 minutes. After the 4 minutes, they want to take out. Okay, when they take out, they just pour into the pantry dish. Okay, now that's prepared by the 2. Okay, put in. After that, you need to close and also seal after that with the lid. Okay, then we go to see this part. You see, after 1 hour, the solution becomes solidified. Become solid already. Okay, next, 7. They use the cotton wrap to collect the bacteria sample. Okay, we see what bacteria they go to collect. Okay, first one, they go to wrap the cotton wrap on the door handle. Okay, go to wrap first. Okay, another situation, they're using another cotton wrap. They go to collect from the your toilet. Okay, the sinking bowl. Okay, after that, they go some more, go to any table lah. They go to collect the sample also. So that means they collect the sample should be the different because the different location. Okay, now we're going to see this part. Okay, what they do. Okay, for this one, you see what to do. Okay, I change first. Okay, go and play. So need to do the shaking all the part. That means let all the bacteria put at the everywhere of the nutrient agar. Okay, after that you need to keep. Okay, close it and keep inside the box. After that, put inside the dark cupboard. Okay, after a week, we're going to see what you see. Okay, we find it like this. Okay, by using the microscope. Okay, I go to zoom, then you can see more clear. Okay, this one is the result they go to see. Okay, so many different shapes. We also don't know what is that. Okay, so this one is under microscope. You can see what is the microorganism, the shape. Okay, what microorganism we still don't know. We got the mixtures already. Okay, so now we continue. Okay, this one. We go to zoom. Okay, this is a video. So you can see what is that. Almost like this. The rod shape. Okay, this one just like the cocos. Okay, another one like this, the bigger size. So this one is a different type of the bacteria. Okay, we don't know what is that. Okay, so now, so if you put your hand, you also got, you put the whole hand on the agar. After 1 week, you find it like this. Okay, you can see different type of the bacteria we produce here. Because your hand don't know how many virus, how many bacteria is on your hand. So that means you can see the shape. Then after that, this one is a bacteria. Okay. So from here, we go through the another part. That means your table form. Okay, observation. So after you see so many things, so I want you to give me the answer for I do a number. You just tell me many bacteria colonies. Then you tell me less bacteria colonies, no bacteria colonies, and a few bacteria colonies. So your 4 answer here is it. So you answer me the first one. Okay. When I just talking about with unwashed finger. Okay, unwashed finger. So your answer should be, oh, Jia say many. Okay, so we compare, we read all first, okay, until the end. So the B one is a wash with water only. C is a soap and also water. And the last one is without any finger. So sure the finger is the most dirtiest one, is it? So from here, the first one sure is a many colonies. Okay, how about the B and C? What's the difference? Which one should be a few? A few and less, we compare. Okay, C is a few. What's the meaning of few and also less? If I let you just compare B and C, a few and less, which one should be the answer for the B?
Less.
Less is a B. Okay, a few and less should be which one more? Which one more? Which one less?
A few is more.
A few is more. So that means you tell me with water only and also with the salt and water, which one should be a few? Rayson answer me, a few sure is a B already. Because B you never wash with any soap, is it? So if I compare a few and less, sure a few a more little bit. Okay, but many sure is a many already lah. So from here the B must be a few. Okay, then the C understood lah. There's a less. Okay, last one. Okay, last one, what's the answer?
No.
Okay, no. The answer is no. Okay, no colonies. Okay, because you don't have any bacteria to go in. You just make it become neutral already, then you close already. Okay, maybe a little bit lah, but the moment you close already, seal already, that means nothing already. So that's why we cannot open, let the microorganism to go in. So from here, okay, we go to answer the conclusion. Okay, is it the hypothesis accepted? Okay, hypothesis, I know we accepted, but we mention later. Okay, the first one, we go to conclusion of this experiment. So the conclusion from the table, what you get it? Okay, we get it is when the clearness level increases, that means the growth of the bacteria should be how? More or less. Okay, if I say decreases, yeah, correct. So that means you can reverse one. You can say when the clearness level become low, and then your growth of the bacteria will be increases. Okay, then baru you go to answer hypothesis is accepted. Okay, that means the hypothesis you bring at the back. So from here the answer is okay, as the cleanliness level decreases, the bacteria growth will increases. Then you say hypothesis accepted. Okay, so this one is a format how to answer the conclusion. Okay, so we go through the next. Next one is your question lah. Okay, the question you need to copy the question and also answer it. Okay, first one, why are the nutrient alga and the petri dishes is sterile? Why they need to sterile? Okay, sterile means you go to steam and make it become hot. Then after that, then you take out. And just like the alga just now, they put inside the microwave. Okay, why they want to sterile? Okay, sterile means the temperature high already. Okay, important, you go and think bacteria can stay in high temperature or not? Cannot. Okay, you say cannot. So that's why when starting, I need to make sure all nutrient must be balanced with no any bacteria. So I need to sterile. So I make it when starting constant variable, all must be same temperature. Okay, I sterile first. Okay, so from here your answer is to kill the bacteria in the nutrient alga and also petri dishes. So before that also got a little bit bacteria one. So that's why you want to kill all first, make it become empty, then we do the experiment. Okay, number 2, explain why the petri dishes are kept in this condition. Okay, first one, cover and lid. Just now I told you already. Sealed with the cellophane tape some more. So the answer is they want to prevent the other microorganism to enter it. Okay, we just want to test about your finger only. Okay, number 2, why they inverted? This one is just now question I asked you why they inverted. Okay, you see the answer. They want to prevent the condensed water from dripping onto the surface of the nutrient alga. Okay, if you terbalik, that means the condensed will go through to the surface of the lid. They don't want to go into the alga, which will affect the growth of the bacteria on the surface of the alga. So they don't want the condensed water that will affect the growth of the bacteria. So they want ori. Ori, that means the bacteria get the nutrient from alga only. They don't want the steam water. Okay, so this one they need to invert it. Okay, see, they keep inside the dark cupboard. Just now Kylie answered already because they don't want the light. Okay, normally they want to grow in the dark area. So from here is to keep out the light, okay, especially the sunlight, which retard. Okay, retard means they slow down the growth of the bacteria. So that means we need to prevent. So that's why cannot put inside the outside the table or outside your classroom. We cannot do like this. Normally we keep inside the dark area. Okay, because we want to increase the rate of the growth of the bacteria. Okay, so this one is the answer for number 1 and also number 2. Okay, then we go to number 3. Okay, which of the following pantry dishes A, B, C has the highest number of the bacterial colonies? Okay, just now we answered already. The answer is A, is it highest? So you tell me why? Why this should be the highest? Pantry A. Okay, pantry dish A should be the highest. Okay, because your unwashed finger have the highest number of the bacteria. So you no need to mention why lah, where you touch lah. You just say because your finger you never wash, sure is the highest number of bacteria on your finger. So that's why they will causes the pantry A will show many of the bacteria colonies. Okay, B also the same thing. They just reverse only. They ask you which one should be the lowest. So the answer should be the C lah, is it? Okay, C is the lowest. Then reason again, your finger have been washed. Okay, some more with the soap and also the water. Okay, after you find it, there has the lowest of the number of the bacteria. Okay, so that means you wash with the soap and also the water that will kill some of the bacteria on your hand. So that's why now they call you every time you need to wash your hand. Okay, the last one is what is the function of the sterile nutrient agar in the pantry dish? D. D and nothing do anything. Why you need to put here? Okay, cannot test what? So anybody can answer? Brian, what's the answer?
To see whether got bacteria or not.
Oh, okay lah. That means same like the jala almost is compare lah, is it? Okay, thank you, Prema. Okay, so we put the D
Okay.
actually. Okay, D actually is one of the control set. Okay, we need to find out. If I never put anything, is it the bacteria still there or not? Okay, if the bacteria still there means your finger not the big affected lah. Maybe the surrounding also got already. The nutrient agar already got already, is it? So that means we need to test one is the original. Okay, the rest is affected by your finger. So that means we need to find out if pantry dish is nothing, means that means your finger is memang put the bacteria inside the agar. Okay, observe different. Yeah, we want to see the observation is a big difference compared with the A, B, and also C. Okay, now how to answer it? Okay, as a control. Okay, there's a control set to compare the result of the experiment. Okay, so this one is one of the comparison with the original. So normally we do the experiment, we need to compare the original. Example, the simple one. I call you give 1 meter rule. You go to measure what is the length of the table. Actual length the table is a 9 meter, but you go to measure how many? 8.5, then 8.7. Why I need to want you to measure? Because I want you to compare with the original. Although I know the original is a 9 cm, 9 meter, but I still want you to measure. So that's why I sure got one of the standard answer. Then after that, the rest you do the experiment, you go to measure. That one, just one thing to support. Okay, to support, you got error when you do the measurement. Okay, so this one is an example for the banded dish. D, they put the ori. After that, let you to do the others experiment. Then they do the comparison. Okay, so from here we find it. When the cleanliness level decreases, then the bacteria, they're more easier to grow at there. Okay, so from here we got next part. Okay, are there any colonies or bacteria growing on the nutrient agar and the banded dish? D. Just now we said already, we do compare, is it? Now you tell me pantry D is nothing, is it? Just now we said no, is it? Then you give the reason. No, because the nutrient agar has been sterilized, all the temperature high already. After that, you straightforward go to silk. Then you prevent other microorganisms from entering. So that means inside is nothing. Don't have any microorganism can be go in already. Okay, although go, although got, but the high temperature already is killing. Okay, so this one is why we're using the petri dish D. Okay, as a reason. So this one is. Then after that, we go through the factor. Okay, we learn 5 of the microorganism. Now we're going to see the 5 factor also that will affect the growth of the microorganism. So we need to see which one situation is most suitable for the growth of the microorganism. Okay, so from here, the first factor, humidity. So that means if the situation they got water, they like so much. Okay, humidity. Yeah. Okay, the next one, light. Okay, we depend the light. So normally they don't want the light one. They want dark area. Okay. Then after that, we got temperature. We're going to see which one temperature is most suitable for the growth of the microorganism. Okay, pH value. So pH value we can find out. We got alkaline, we got acid, we got neutral. Okay, later we're going to see the microorganism where they want to stay. Yeah. Okay, and the last one is the nutrients. Okay, where they can get the nutrient, sure they want to stay there. Okay, so now we're going to see one by one. Okay, first one, we're going to see the humidity, damp condition. Okay, promote the growth and also reproduction of microorganisms. So this one they like so much. Okay, after that they can grow faster. They also got reproduction some more. Okay, if the humidity area. Then we go to the continue. For the dry condition, they do like. Okay, they will cause the microorganism to become less active and also retard their growth. Okay, just like you lah. Let you go to the area is very hot. Okay, hot weather, you're also not comfortable, is it? Okay, so that's why the microorganism also same lah. If the dry area, they also don't like. Okay, then the growth becomes slowly some more. So this one is how you want to avoid the microorganism in your body. So we need to keep clean and also dry from your body. Okay, so this one is one of the factor. Let the microorganism, they're easier to be grow. There's a humidity. They need the damp area. Okay, the second one should be the light. Okay, light just got one of the microorganism, they want light only. Which one? Okay, we got 5, is it? One, they want the light. The rest, they don't want.
Okay.
Yes, algae, because algae, they got chlorophyll. Okay, chlorophyll, that means they want to process the photosynthesis, get their own food. The rest is no. The rest is a parasitic and also saprophytic organism. Okay, so from here you can see the light factor. Okay, the microorganism will process the chlorophyll, require light to carry the photosynthesis. So this one just a little bit bacteria. Then the rest is algae. Okay, microorganisms such as a fungi or you say the bacteria, they are grow better in the dark. Okay, they don't want the light. Okay, exposure to the ultraviolet light. Now you know that our sunlight is ultraviolet light already. Too high temperature that can be kill the microorganism. So that's why you need to keep. So you got listen some of the new. You want to kill the virus in your body. What to do? You drink the warm water. This one, don't know lah. Is it got logic or not logic? Okay, because they say high temperature they can kill the bacteria. Okay, so another one is light. So better you go where? You go to under the sunshine. Okay, under the sunlight. After that, you kill the bacteria in your body. Okay, example lah. This one is a one example only. But you need to know the microorganism that don't like the light. Okay, when they want to grow. Okay, next we're going to see is a temperature. Okay, we can see the temperature. What temperature is suitable for the microorganism? Okay, temperature 35 to 40. Is it your body temperature? Your body temperature, how many? Every day you go to sensor from the infrared lah. Okay, what's your temperature in your body? Normal one.
36.5.
36.5, your normal. Okay. So almost like this lah, 36.5, then 36.9. So normally we did over 37.5, is it? So from here, they say 35 to 40, this most suitable for the microorganism to stay. So that means your body, they like so much. Okay, Okay, because there's an optimum temperature for the growth of microorganism. Okay, some more low temperature they don't like. Okay, such as in the refrigerator. Okay, refrigerator until -3, -4, or you say until 2 degrees Celsius, they also don't like. Okay, they will make it become slow down to grow. Okay, high temperature they also don't want. Okay, 100 degrees Celsius I also don't like, because they will kill the microorganism. So that's why they call you to drink the water must be boiled water. Okay, you need to boil the water, make all the microorganisms kill first, then the baru can be drink. Okay, so this one is a reason why we need to boil the water. Okay, another thing you need to take care, because microorganisms, they like to stay, the temperature is exactly our body temperature. Okay, so now we go another one. There's a pH. Okay, pH value. Okay, when you write a pH, you must be very careful, because this one is the chemistry standardized. P must be small letter, then the H is a capital letter. Okay, if you're wrong, they will minus your mark. So better you write correctly. Yeah, P small, H is a capital. Okay, we're going to see the pH value. Okay, let's see the table here. Okay, the center one. This one is a neutral. Our body is neutral. Okay, or you say the normal water we drink, that one is a neutral. Okay, so this one is above the neutral one. Okay, neutral is a 7. 7, we count by number. 1, 2, 3, 4, 5, 7. Okay, this one didn't count for bar. Just 0 until 6, there's an acid. 0 until 6, there's an acid. So that means this bar 7 should be the neutral. Okay, 2, 4, 6, 7. Yeah, count from 0. 0, 1, 3, 2, 3, 4, 5, 6. So 7 should be the neutral. Okay, after that 8. 8 until 14. 8, 9, 10, 11, 12, 13, 14. That one is an alkaline. Okay, so that means the pH value for the microorganism, they don't like acid. They also don't like alkaline. They like neutral. So 7. So that means they like your body memang so much. Okay, temperature ngam, then your pH value also ngam. They like so much. So from here you're going to see pH 7 is the neutral pH. That is the optimal pH value for the growth of the most microorganism. Then there are the certain microorganisms that can be live in slightly acidic or alkaline. A little bit alkaline, okay lah. Acid also okay. But the most suitable should be the neutral. Okay, so you jaga bye-bye. Okay, the next, nutrients. Okay, where to get the nutrients? Okay, let's see here. The growth of the rate of microorganism that increases with presence of the sufficient of the nutrients. Okay, if more sufficient, better lah for the growth. Okay, then the growth of the rate of the microorganism will be retarded even with the presence of the nutrient when the other factors such as the humidity, light, temperature, and pH value is limiting. Although you got food, but suddenly you say, oh, this one is very acid one. Acid is a 2. So that means they also cannot stay longer, although they got nutrients. So they still need to depend for the others factor. Okay, you just say dry area, but inside got so many nutrients, they also cannot stay because their light is a damp condition. Okay, so this one is a 5 of the factor will make the microorganism how to grow. Okay, important is the others like nutrient, not important. Important is the temperature, pH, and also the humidity. So for your body already is a humidity, inside is a damp condition because you can drink the water. After that, light, your body inside sure is a dark one. Don't tell me it's a light one. Okay, then after that, temperature, your body temperature also more suitable already. After that, we got pH value, that's a neutral. Nutrient, no need to say your body full nutrients because every day you eat, is it? So that means that's why the virus, they want to stay our body. Okay, this one is the reason. Okay, and also after one body, they change another body some more. So this one is why they keep changes and also keep increasing. Okay, so this one is a 5 factors will make the microorganism to grow. Our class just finished until here. Okay, thank you. Bye-bye.
Teacher.
Okay, bye.
Okay, thank you, teacher.
Okay,
Bye.
bye.